Homework 12, Polynomial Division, Factor Theorem, Rational Zero Theorem, Video 3. In the first two videos, I want to say reviewed long division, because in theory, you've probably seen it before. But long division is called long division for a reason. It's long, it's cumbersome, and I've seen long division problems that will go 10 layers deep. Pretty ugly. However, there's a variation of division called synthetic division that is much more concise, takes up less space, and frankly is quicker to do. Comes with a catch though, it doesn't always work. It's only valid if a divisor, don't know what that is. If a divisor is degree 1 and the leading coefficient is 1. What does that mean? It only works if the divisor is x plus a number, we'll call it x plus c, or x minus a number. So it's very particular on when you get to do it. No powers except 1, no number in front of the x, but as long as your divisor is x plus a number or x minus a number, you can use synthetic division. So let's take a look at this example, and I'll use it as a means for describing how to perform synthetic division. We're going to divide x to the third power plus 7x squared minus 13x plus 11 by x minus 3. Now, how do you do synthetic division? Synthetic division is made up of three parts, if you will. Part number 1 in synthetic division is the setup. The setup has 2 parts to it. Now, before I give you those 2 parts, let me kind of describe how it's going to look when it's all said and done. Synthetic division is going to be 3 rows of numbers. The top 2 rows are going to be separated by the third row with the horizontal line, almost as if we were setting up a big addition problem. And to the left of the top row is going to be an extra number that I'm going to put in a box. I will call it the box number. So these arrows aren't really part of the process, they're just me pointing to where the rows of numbers are going to be. One row of numbers, another row of numbers, third row of numbers, separated by the top 2 with the horizontal line. So here are the 2 parts of the setup. The top row is equal to the coefficients of the dividend. In other words, the part you are dividing into. So you look at your dividend, which is right here, and you pull out the coefficients, so the numbers in front of all the x's. You do not write any x's in synthetic division. The whole plan is to take out the x's and just work with the numbers. So for the top row, the coefficients from left to right are 1, don't forget there's an implied 1 here, 7, negative 13, keep the negatives, and 11. Make sure you keep your numbers spaced out so that they don't run together. The other part of the setup is the box number, the number that goes in the box. And it comes from the divisor, but it's the opposite of the number that you see. It's the opposite of the constant in the divisor. So you look at the divisor, and there will be a constant at the end. This constant is negative 3. When you put it into the box, you change its sign. So instead of a minus 3, it's a positive 3. And that's all there is to the setup. We've basically taken all the x's out of the problem and changed one sign. I'll tell you right now that the reason we changed the sign is to take care of all the subtractions later. Do you remember when we did long division and every time we subtracted, we had to change all the signs? This one sign change will take care of all of them. So hooray. So that's all there is to the setup. Coefficients of the dividend in the top row, opposite of the constant in the divisor, in the box. After you set it up, the second part of synthetic division is the work. And just like the setup, the work has 2 steps. That being said, I'm going to put A, B, and C. C is just going to say repeat. When you do the work in synthetic division, you no longer think about rows, but about columns. There is 1 column for each coefficient that you set up. So this synthetic division problem is going to have 4 columns. You start in the first column. In the first column, you add. And you might be thinking there's nothing to add in the first column. And you're correct. What most teachers in most books will say is bring down the first number all the way down to the third row. I like saying add up the column because that's what we're going to do with the rest of the columns, so it's consistent. If you add up everything in the first column, it's just a 1. That's all there is. For your next move, you multiply diagonally by the box number. The number in the box is a multiplier. Sometimes you'll see a little X out there for times 3. But after you've added a column, your next move is to go diagonally. And when you go diagonally, it will take you to the next row, to the next column, but back up a row. So the direction it goes is there. And when you go diagonally, you multiply by whatever is in the box. So in this case, 1 times 3 is 3. You don't have to draw the arrow, it's just an instructional tool. But the third part of the work is to repeat until you add the last column. So now that we're in the second column, we're going to add again. 7 plus 3 is 10. And then after you add, you multiply diagonally by the box number. 10 times 3 is 30. That puts us in the third column. So we add again. Negative 13 plus 30 is 17. And now that we've added, we multiply diagonally by the box number. 17 times 3 is 51. And then you add up the last column. 11 plus 51 is 62. That's all there is in the work. You add and multiply. It's a lot more efficient than long division. In long division, my apologies if you're reading the closed captions because this next part's going to go fast. In long division, you have to divide the leading term of the dividend by the leading term of the divisor. Write that result as the first term in the quotient, multiply it by all the terms in the divisor, write the product underneath the dividend, change all the signs in that product, combine like terms, you should cancel the first term in the dividend, bring down the next term in the dividend, and then do it again, and again, and again. Whereas in synthetic division, all that you do is add, multiply, add, multiply, add, multiply, add. Just to remember, when you go vertically, you add. Vertical is half of a plus sign. And when you go diagonally, you multiply. That diagonal is half of a times sign. I came up with that gimmick. I'm proud of it. Oh, but we're not done. We're doing a polynomial division problem, and right now all we have is a row of numbers. You start synthetic division by taking the x's out. The way you finish it, put the x's back in. The third and final part of synthetic division is the answer. And just like everything else, it's made up of 2 parts. The bottom row is the coefficients of the quotient, but lower the degree by 1. Now, what do I mean by lower the degree by 1? Well, before we divided, the degree of this polynomial was 3. After we divided, the degree is going to be lowered by 1, and it's going to be 2. So when you put the x's in, you don't put them in the same way you took them out. You knock them down a power. And the main reason is pretty easy to explain. If we were doing a long division problem, our first move would be x to the third divided by x, which would make it x squared in the answer. So when you put the x's back in, lower the degree by 1. So this 1 represents 1x to the x to the second power. This 10, which is positive, represents 10x to the first power. Don't really need that 1. And then the next number, well, 2x's, 1x, no x, is the constant. And what should happen is you should run out of x's right before you get to the last number in the bottom row. That's because, part B of the answer, the last number is the remainder. So to represent the last number of the answer, do the same thing we did with long division. Put the remainder on top of the divisor, which was x minus 3. Add that to the rest of the answer. Ta-da. Synthetic division is much trickier to explain than to execute. So to make my point about how efficient this is, we're going to do another synthetic division problem that's going to look like a long problem and really won't take much time at all.